Hi, we are the ones at the Scua team. This is our proposal for the 2022 Lasc Satellite Challenge. Our mission consists of an unmanned aerial vehicle launched from a rocket performing a controlled descent. The aircraft is equipped with a flying control system adding autonomous navigation capabilities. Inside is fitted as a payload a collection data system for atmospheric condition measurements such as barometric pressure, temperature, humidity, and other important variables for the development of vertical atmospheric profiles. In order to fit a flying vehicle inside a 2 units Kansas volume, we decided for a foldable wings configuration with 3D printed parts conforming the structure, which is a bio-inspired mechanism based in the bird's alar structure and a flexible membrane simulating the feathers. The wings structure is conformed by two 4-bar mechanisms, linked between them in a way that the actuation of one part results in the deployment of the whole wing. The actuation is made by a spring located inside the fuselage, and a nylon string directs its force to the mechanism. A long screw located in each one of the wings is retained by a C-shaped slider that will be actuated by the pitch control servo, releasing the wing and leaving the space for the control mechanism to move once the deployment is completed. A gimbal mechanism located in the tail section allows us to orientate the motor while rotating it about 2 axes, changing the thrust vector direction and then generating reacting forces that will result in the yaw and pitch control of the aircraft. This mechanism is actuated by 2 small servos that will be connected with push rods to the mechanism. The fuselage has a cylindrical shape, with 2 cutouts for the wings mechanism and a rounded nose for have good aerodynamics performance, and it is made by 3D printing. The nose and middle section of the fuselage are free of mechanical components, leaving enough space to fit the electronics and modify the center of mass. As a motor, we are using a 20mm cordless motor with a 6 cm propeller, generating up to 30 grams of thrust.
The Kansas has different electronic systems. The power subsystem provides 5, 4.2 and 3.3 volts through back voltage converters with capacity to deliver up 3 amperes. The central computer is an ESP32, which reads information from avionics such as orientation, acceleration, compass, and GPS. This data is sent to the ground station through LoRa modules. At the same time, is stored in a ESD card. As payload, we have sensors to measure carbon monoxide, carbon dioxide, nitrogen dioxide, ammonia, volatile organic compounds, temperature, humidity, and a video that will be recorded by an ESP32 cam. This video will be sent to ground station via Wi-Fi. This ESP will also work as a redundant telemetry system. These subsystems are integrated in SMD components on 2 4-layers PCB to optimize the space inside the CANSAT.
The OneSat flight computer is composed of an ESP32, and the payload subsystem is composed of an OB26 camera and other sensors. To send all of this information through the communication subsystem, we use LoRa to transmit housekeeping and sensor measurements to the ground station with a range of up to 10 kilometers. Unfortunately, it has a low data rate. On the other hand, to take advantage of the ESP32, we decided to use the long range operation mode to transmit pictures of the Kansas trip. For that reason, we improved the communication subsystem, especially at the receiver stage, using a high gain parabolic antenna and an omnidirectional dipole antenna in the transmitter. Please be alert for the next updates on our project.
Now we're gonna present you our estimated budget and our schedule for the next days. We have already prepared our first prototype. On the next days, we're gonna be making some simulations and flying tests.